Hi students, problem number 6. Two long and parallel straight wires A and B carrying currents of 8 ampere and 5 ampere in the same direction are separated by a distance of 4 centimeter. Estimate the force on a 10 centimeter section of the wire A. So I will consider the first wire as A and the second wire as B. The current in the first wire is I1. So the value of I1 is given as 8 ampere. So this is 8. And the current in the second wire B, that is I2, is equal to 5 ampere. The perpendicular distance of separation between the two wires, that is A, small a, that is equal to 4 centimeter. So this is 4 into 10 power minus 2 meter. Now both the current carrying conductors are parallel to each other. So we have derived an expression in the theory class. What is the force per unit length? Force per unit length. Do you remember? Force divided by a given section L. For two infinitely long straight wires we have derived. So here I will write force per unit length is what? F by L. This is equal to mu naught into I1 into I2 divided by 2 pi A. This is the expression per unit length. Therefore, for the given section L, okay, this is F is equal to mu naught into I1 into I2 into L. This L is coming up divided by 2 pi into A. So this is per unit length of the wire. So for a given length, what is the given length is 10 centimeter. So the L is equal to 10 centimeter. So this is 10 power minus 1 meter. Okay, we can represent in the SI unit, 10 power minus 1 meter. So I am going to substitute the given values. Therefore, what is that force required is equal to mu naught. This magnetic constant is what? 4 pi into 10 to the power of minus 7. This you have to remember. You have to write and remember. Okay. So 4 pi into 10 power minus 7 multiplied by I1 into I2 is what? 8 into 5. So this is 8 into 5 into this length, okay, of the wire is 10 power minus 1 meter. So this is 10 power minus 1. So numerator we have substituted and divided by, in the denominator there is 2 pi. So this 2 pi into, what is A? The perpendicular distance between them is 4 into 10 power minus 2. So this is 4 into 10 to the power of minus 2. Now all numbers are easy to be cancelled, but you should be very careful while cancelling. See here, this pi term and pi term is getting cancelled. Is it not? So here 2 into 4 is equal to 8. I can do in any way. Okay. So 2 into 4 is 8. That is convenient for me. So in the denominator 2, 4 and pi are getting cancelled. Only this 10 power minus 2 is brought up as 10 power plus 2. Okay. So what are the remaining terms? So F is now equal to 4. 4 is there into 10 power minus 7 is there into 5. Okay. Into 10 power minus 1. This is 10 power minus 1. When this 10 power minus 2 is coming up, this will become 10 power plus 2. Okay. You should be very careful with the powers of 10 also. So what is this? 5 fours are 20. Okay. Therefore, F is equal to 20 into, this is 10 power minus 7, 10 power minus 1 if you add 10 power minus 8. This is plus 2. So 20 into 10 to the power of minus 6. Or this also can be written as, F is equal to 2 into 10 it is, 2 into 10. So this also can be written as 2 into 10 power minus 6. Therefore F is equal to 2 into 10 power. Okay, this is 1. So minus 5 Newton. So this is the required answer for this question. So which is the option correct answer? Option A is wrong. Option B is found to be correct. Is it not? 2 into 10 power minus 5 Newton. Therefore option B That is, force is equal to 2 into 10 to the power of minus 5 Newton. This is option B. Therefore, option B is the correct answer. Okay, have you all understood? I hope you must have understood well. Fine.